So in this section, we're going to be looking at context-free constraints, context-free markedness constraints, and these can also be referred to as inventory constraints. They basically govern what combinations of features or what particular feature values are allowed in each language. And we've seen some of these last time already. These would correspond to rules or constraints that can be stated as applying in any context. And we're going to use these words interchangeably: the phonetic or phonological context, the position, or the environment. These all mean basically where do these features occur or not occur, and in what values. So we've already seen a bunch of examples of these. So we looked at vowel systems for the last few weeks, where we saw that many languages allow only rounded vowels in the non-low back part of the vowel space, and only unrounded vowels in the front part of the vowel space. And we saw that you can model these as either a markedness constraint that says, hey, don't have this combination. The relevant combination here would be, for instance, unrounded back mid or high vowels, so non-low vowels. That's the constraint stated as a markedness constraint. You can also write this as a phonological rule, and the rule is a little bit trickier because it not only says get rid of this combination of features, but it makes a prediction about what happens to inputs like this if they get adapted into the language. And so here you'd have to make some kind of a hypothesis about what happens to these, and you might want to say that back non-low vowels are predictably round. And this is going to be true everywhere. Now this part will often just be left out if it's an everywhere kind of constraint, but I'm just trying to do this to make clear that in the context of every context. You can also just leave this entire part out and have only back non-low vowels are predictably plus round, right? So that's going to be a constraint that holds in a number of languages: English, Spanish, Arabic, Swahili, a number of other languages that I mentioned in the last few weeks. We talked about the availability of ejectives and dorsal continuants in English. Neither one of them is a possible sound of English. And again, we can model this in constraint form, where the feature for for ejectives is going to be constricted glottis. And so we could just say, hey, don't have sounds in English that are constricted glottis, or don't have sounds that are plus dorsal and plus continuant, because we don't have any dorsal fricatives or liquids or sonorants or anything like that. And we can also write these as rules, but again, we're going to have to predict what happens to segments like this. So we might say, for instance, that if an English consonant is predictably minus constricted glottis. And that would predict that if you got a sound that was constricted glottis that tried to enter English, or that was being judged by a speaker who has the grammar of English in their head, that they would turn it into a non-ejective stop. Similarly, for dorsal continuants, you could decide that if you get a dorsal continuant in the input, you're going to turn it into a stop in the output. So ch would become ka. That would be dorsal consonants are predictably minus continuant. You could also decide that maybe if you get a dorsal continuant, you're going to change its place of articulation or something like that. So maybe ch predictably becomes sh or something like that in English. And the rule forces you to pick one of those analyses where we don't necessarily have much evidence about that yet. We'll see some kinds of evidence that we can use for these mappings in a week or two. But yeah, right now I just want you to be conversant with both the markedness constraint formulation of these as well as the rule formalism, which says what would happen to the ill-formed sequence in question. And these constraints all affect the inventory of a language, and that's going to be the set of sounds in a language that can differentiate lexical items and that occur in lexical items. There's another way of formulating this in terms of phonological predictability, and this is going to be super important in this class. The idea is that if a sound predictably has some properties, then those properties can't be contrastive. So these constraints would say that some feature values are predictable in English or in Spanish or Swahili. So for instance, a sound that's a back non-low vowel is predictably plus round in English. You don't need to know anything about the particular lexical item in question in order to know what the value of this vowel is for roundness. It is predictable. It has to be rounded. Another way of putting this is that for sounds with these features, or in this context, the feature plus or minus round is not contrastive in English. You can't have lexical items that are distinguished only by the plus or minus round value of a non-low back vowel. This feature is predictable given these features. Right? Similarly, if you're any kind of a sound in English, your value for constricted glottis is predictable. It is predictably minus. Right? So the feature constricted glottis is not contrastive in English. It can't be used to distinguish lexical items. We don't have contrasts in English like coop and coop. Right? These are not possible contrasts in English. So predictable information is non-contrastive, and by hypothesis, it's not stored in the lexicon. This is to be distinguished from unpredictable information, which is contrastive and is stored in the lexicon, and we'll get to that in one of the following sections. Right? If I tell you the thing I've put on the handout here involves not vowel rounding, but the dorsal continuant constraint. So if I tell you that an English word has a dorsal consonant in it, you don't need to know which word it is in order to know that the consonant in question is minus continuant. Right? So if I tell you, hey, there's this English word, and it has a dorsal consonant here, and then it ends in the sequence oop, and I ask you, do you think this dorsal consonant is going to be plus or minus continuant? You don't need to know which word I'm talking about in order to know that it's going to be a non-continuant, because English doesn't allow dorsal continuants. So the value of the feature continuant for a dorsal consonant in this position is predictably minus continuant. And this is phonological predictability that we're talking about. Of course, if you know what the lexical item is, then everything is predictable. But this is specifically about phonological predictability. Can you predict the value of a feature based only on the surrounding features and sounds? Right? So we can also predict that if this is a dorsal consonant, it's going to be minus uvular, right? We don't use uvular articulations in the general case for dorsal consonants in English. It's going to be minus constricted glottis, because this is predictable in English for all consonants, so on and so forth. This kind of phonological predictability is good in a particular kind of computational sense, because it means that these properties don't need to be memorized in the lexicon at all. Right? You don't need to keep this word in memory with a value for you don't need the value for continuancy here in your lexical entry, because it's predictable that it's going to be minus continuant. So you don't even need to store that feature value given these other feature values. Instead, we can store this kind of constraint as a generalization that holds across all lexical items, that holds across the entire lexicon. That's what our grammatical knowledge of a language is. It is these stored generalizations, and one of the things that they do is they excuse us from having to memorize millions of bits of information in our lexicon, and this is in some sense more efficient. We don't need to memorize this in the lexical item because we know that English enforces the generalization that dorsal consonants are minus continuant in all contexts. So every language has a fixed inventory of consonants. Sorry, fixed is probably not the right word to use there. Of course, these things can change and do change over time, but every language has an inventory of consonants. And for the next couple of weeks, we're going to be looking at a bunch of examples in Maori, which is an indigenous language of New Zealand. And it is an Austronesian language, not related to English. And it has a relatively simple inventory of consonants and vowels, although the grammar is quite complicated in other ways. And this is why it's a sort of good example here. It also allows far fewer phonological structures than English does, and so there's going to be a useful comparison here. So we're going to learn a little bit about Maori for the next couple weeks. And as you can see here on page 1, Maori has an inventory just like every other language in the world. In this case, the inventory of Maori is a fair bit smaller than the inventory of English. So you can see they have, let's see here, 4, 8, 9 contrastive consonants in Maori, and that's less than we have in English. They have 5 contrastive vowels, just like Spanish, and just like that most common vowel system that I mentioned a few weeks ago. This is some form of the I-A-A-O-U system, which is the most common vowel system in all the world's languages. So Maori is going to have this exact same constraint, as well as the one against front-rounded vowels. And that appears to be cross-linguistically very, very common. So here are some inventory constraints on Maori. Illegal feature values and combinations of feature values, just like English, except the specific content of the constraints is going to be different because Maori has a different inventory. And these are all going to be Markowitz constraints that apply everywhere or in every context. These are context-free constraints or context-free rules. This is important because shortly we're going to look at other generalizations and constraints that are not context-free, that are restricted to a particular context. But for now, we're looking at context-free rules. So one thing to notice here, Maori has no lateral consonants. There is no la sound or yes sound or any other kind of lateral sound in Maori. And so we would posit a constraint star plus lateral. Or if we wanted to write this in the rule format, we could say that consonants, or really it's any sound, but let's just say consonants, are predictably minus lateral in Maori. And again, this is going to hold everywhere. We're just going to leave that out to indicate that there's no particular context in which this generalization holds. It holds everywhere. Interestingly, Maori does not have any minimal voicing contrasts. So in English, tip and dip mean different things. The feature plus or minus voice is minimally contrastive. That has to be stored in our lexicon. But in Maori, if you have a stop in that position, it's predictably minus voice, and it is in every other position as well, and that's true for both stops and fricatives. So there are no voiced obstruents in Maori. And again, we can write this as a prohibition on a particular natural class that comes from combining some features. In this case, obstruents are minus sonorant, and voiced consonants are plus voice, and we would prohibit the combination of obstruent minus sonorant and plus voice, no voiced obstruent. So again, that's a context-free constraint. If we wanted to write it as a rule, because there's more than one feature here, we're going to have more than one choice about how to write that rule. We could say that it's equally correct at this point to say that obstruents in Maori are predictably minus voice, but we can also state this in the form voiced consonants in Maori are predictably not obstruents. They have to be sonorants, like the nasals and the approximant r that we see here, as well as vowels, right, are going to be voiced in Maori. So either one of these is a possible way to write this generalization about Maori. And in the rule format, we have to sort of pick one and say what would happen if you did get a voiced obstruent in the language. In the constraint format, all we have to say is that you can't have these two features together. You can't have voiced obstruents. There are no strident fricatives or affricates in Maori, no sa, fa, sh, ch sounds. There is a fricative or two fricatives in Maori, but neither one of them is sibilant or strident. We have a bilabial voiceless fricative hua, which is made with the Greek phi sign in the IPA. And you have the glottal fricative h, which is voiceless but non-strident. And there are no strident fricatives in Maori. So again, a filter, star plus strident. All sounds in Maori are predictably non-strident in all contexts. Just like English, we find no front-rounded vowels, just like Spanish, just like Swahili, just like Arabic, just like many, many languages of the world. You can't combine the features minus back and plus round. There are no non-back rounded vowels in Maori, just like many of the other languages that we've looked at in this class. And that's, again, going to be true in all contexts. And so what each of these constraints is saying is that you don't need to memorize all of this information in your lexical entries because it's a predictable, phonologically predictable property of the language. In this case, it's predictable based on the inventory of Maori, and we simulate or model that inventory by saying, well, there's just a series of inviolable constraints in Maori that prohibit sounds that are not allowed to occur. That's what an inventory is. So at a first pass at fleshing out this kind of formalism, we're going to need to distinguish legal from illegal feature combinations using these constraints. And you can see this sort of listing of context-free constraints or inventory restrictions as a set of demands that Maori words have to satisfy. And so this is shown in a table or tableau on page 2 here. And the basic idea is that we have all of these markedness constraints: star plus lateral, star minus sonorant plus voice, star plus strident, star minus back plus round. And then for each potential Maori word that comes from our rich base, we can ask, hey, does this one satisfy the constraints? And we'll mark that with a check mark. Or does it not satisfy the constraints? We'll mark that with an asterisk. And so these first 4 words in this tableau are actual Maori words: rimo, takahe, haka, and totara. And these are existing Maori words with the meaning shown in the tableau. And these satisfy all 4 of the markedness constraints. And of course, there's more markedness constraints. We're just focusing on a few of them here. And then by the same token, we can explain why certain other kinds of potential words are not possible in Maori. So limu is not a possible Maori word. Why is that? Well, it contains a lateral consonant, and so it's going to violate that constraint, star plus lateral. Dakahe is not a possible Maori word because it contains a voiced obstruent, namely a voiced coronal stop. Saka is minimally different from haka, but it's not allowed in Maori because that first fricative is a strident fricative, and we have a constraint against stridency in Maori. So totara is a type of tree that's licit, but totara is not a possible word in Maori because it contains this mid-front rounded vowel u, and that violates the prohibition on non-back vowels that are plus round. Right? So the idea is that Maori words have to satisfy all these constraints in order to be Maori, in order to be producible by the grammar. So this is a first pass at what the constraint formalism looks like. This is going to get revised.